Hey guys, gonna get you started on the unions and intersection homework for the weekend. I'm not gonna do the hard ones. I'm gonna do 1 and 2 to give you guys a good head start on it. So we're gonna use the knowledge of unions and intersections of sets to answer the following questions. The first thing we're gonna do is give the union and the intersection of A and B. So let me write how we are gonna note that. We'll have the union of A and B, and then we'll have the intersection of A and B. And when we're talking about the union of these two sets, remember we're talking about all of them together minus their intersection, because this means A or B, and we're not going to repeat them. I see a couple repeats, 3s, 12s, 22s. We're not going to repeat those. We're just going to list all the numbers that appear in either A or B. So let me go ahead and do that. Alright, so you can see that I've listed 0, I listed 1, I listed 3, but only one time because it's the same number. It just happens to be in both sets, so it's in either A or B. 5, 6, 12 is only listed once, and so on all the way up to 30. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers in this set of the 15 that appear in either set. Alright, and then the next one is pretty simple. Usually the intersection is a lot smaller than the union. These are going to be all the numbers that are in either A, or that are in A and are also in B. So that's just 3 is in both, 12 is in both, and 22 is in both. So that's the intersection. That's just all the numbers that are in both. So then 2 has got some people confused. They're sending me reminds, wondering what this means. All this is just verifying this statement, this formula that we created in class on Friday, using the two sets that we have. So maybe I'll zoom down so we can see those sets. It's saying P of some X event or some Y event happening is going to be equal to the probability of that X event happening plus the probability of that Y event happening minus the intersection of those two events. So we're just going to show that that's exactly what's happening here with what we've just done. Using the sets we already have, we'll say A is our X event and B is our Y event, and we can see that that is this set. So we're going to show that the probability of X happening plus the probability of Y happening minus their intersection is going to give us that A union B. So what I'm going to do is I'm going to list out all the events that happen in set A. So that's all of our set A. And let me use another color here. I'll use green. And we'll say that the green events match up with probability of being in set A. Alright, now I'm also going to add the B events. Alright, so there's all the events in B. And I'll use yellow to highlight those B events and show that those go with our set B. So what we're trying to show here is not just probability of A plus the probability of B. We're also showing that the probability of A or B is going to be those two probabilities added together minus their intersections. So the intersection is going to be any number that appears in both. So let's say the intersection here is going to be 3 is in our intersection, so we'll take out a 3. 12 is in their intersection, so we'll take out a 12. And 22 is in their intersection, we'll take out a 22, and just to show that it doesn't matter which set I take it from, I'll take this one from A. So that's going to leave us with the following set. Let me write it out. And now that we have probability of A plus the probability of B minus their intersection, you can see that what we have here is actually the exact set that we found when we found A union B. So we're just showing that illustration using those two sets. It's not anything too crazy complicated. It's just another way to illustrate that concept and that formula we came up with on Friday. All right, good luck with the rest of the homework, you guys, and I'll see you all tomorrow.